welcome back to the Cracking FAANG YouTube channel. I want to apologize for the lapse in videos. My MacBook Pro died on me, and by the time I got it repaired from Apple, it's now been 2 weeks later, so hence the lack of videos. Anyway, we are now back, and today we're going to be solving 282 expression add operators. So let's read the question prompt. Given a string num that contains only digits and an integer target, return all possibilities to insert the binary operators plus, minus, and or multiply between the digits of num so that the resultant expression evaluates to the target value. And note that operands in the returned expression should not contain leading zeros. So let's look at an example and think about how we might solve this problem. So we're given the nums 1, 2, 3 and the target 6. And we're essentially told you're allowed to place anything between the digits as long as it's a plus, a minus, or a multiplication. And however you arrange, those values, it doesn't matter. All that matters is that your final target is 6. So I guess let's look at one potential answer here. And we can actually see that if we multiply all the values, we're going to get 6. So if we simply put multiplication between all of the values, we'll get 1 times 2, which is 2, times 3 equals 6. So this is one potential solution. And what could be another solution? Well, actually, if we add all the values, we can also get 6, right? So we can get 1 plus 2 plus 3, and this equals 6. And note that even though we're using single digits here, we could actually do something like 12 plus 3. We could do something like 12 minus 3. We could do 1 minus 23. So we're not bound to just using a single digit, right? So essentially what we want to do is we just want to figure out all of the ways that we can actually get our target value here. And unfortunately, there really is no trick to this question. What you want to do here is just, a depth first search and with some backtracking to generate all possible values. So essentially what you're going to do is you're going to start at the first value and you're going to say, okay, what are the 3 paths I can take from here on the next value, right? And there's actually 4 paths, and we'll see why. So we can say, okay, with the 1 on the next value, we can do 1 plus 2. Or on the next value, we could do 1 minus 2. And then on the next value, we can do 1 times 2. And then continue on, right? So we could have 1 plus 2, and then we could do 1 plus 2 plus 3. We could do 1 plus 2 minus 3. We could do 1 plus 2 multiplied by 3, and on and on and on, until we exhaust all of our values. And then at the end, we can actually evaluate all of these expressions. So this is 6 here. This is going to be 0. So obviously that doesn't work. This one is going to be 7 because we want to deal with order of operations. So what we do is just we build all the possible values, and at the end we're going to check whether or not they equal our value here. And if it does, then we can add it to our result and we're good to go. So the way that we want to do this is we want to, like I said, do a depth first search, and we're going to be using some backtracking here to basically explore all the possible options. And what we need to do is we need to keep track of, our current index, because that's going to tell us where we currently are, right? So we need to keep track of our index, pretty straightforward. What else do we need to keep track of? Well, we need to keep track of the, solution that we've built so far, right? So here, if we were at the point where we're doing the 3, our solution state so far would kind of look like the string 1 plus 2, right? So we need to keep track of where we are at each stage. So we're going to say the current result is what we want to keep track of, right? We want to keep track of our current result. And we also want to keep track of the current sum, because obviously we don't want to be evaluating the sum every single time. We kind of just want to be doing it on the fly as we go. So we're going to say the current sum. And that way, when we get to the end, we don't then have to sum over everything. We can simply just check whether or not the current sum equals the target. So, and then the current number is the last thing that we want to keep track of. Obviously, we just want to keep track of that. And the reason that we actually want to keep track of the current number is because you have multiplication. And with multiplication, unfortunately, we're bound by the order of operations, right? So if we were going left to right, obviously we would process the 1 and the 2 first. So technically we would have added 3, and then if we multiply by 3, we'll get 9. But we know that our solution is 7 because we need to actually multiply the 2 and the 3 first and then add the 1, which gives us the 7. So the reason we need to actually keep track of the current number, which when we get into the next iteration will be the previous number, is that we would need to undo any sort of addition that we did before, and then we would multiply our current number times the previous number to get that result, and then we'll add back the value that we had added previously. And this is only in the case of multiplication. If it was just addition and subtraction, this problem would be a lot easier, but unfortunately we have to essentially keep track of the multiplication case here. So we are going to need to undo any sort of addition or subtraction that we may have done in the case that we have that. And one last thing that we want to be careful of is this thing here, right? We don't want to have anything that contains leading zeros. And what might that look like? Say our numbers are 105, right? And we know that we could split this like 1 plus 0 plus 5. That's fine. We could split it like 10 plus 5. But what we can't actually do, and if we kind of make some more space here, we can't say 1 plus 05. This is not a valid number. We cannot do this because obviously the numbers should not contain leading zeros. So we're going to need to add a check in our code to actually make sure that if we have a 0, then we want to force going on to the next value. We don't want to accidentally keep parsing it as if it was one number, right? So if we had like 1, 2, 3, we could parse the 1, but then we could also build a 2 out of it and then make it 12 and then add the 3, right? We can't do this when we have a 0 because again, we cannot have leading zeros, so we can't do the same thing that we did with the 12 here. And similarly, if we did 1 plus 2, we could then make that 2 into a 23 if we wanted, but again, we can't do that with the zeros here. So that is how we want to solve it conceptually. But what we're going to do now is we're actually going to go to the code editor because I think it's going to be a lot simpler. This question, obviously, it's a depth first search with backtracking, so there's a lot of possible options that we could take here. For each path, we have basically 4 routes that we could take, and essentially we want to enumerating this for all the possible values, it's going to get real messy real fast, and it's easier for me to actually just go into the code editor, type this up for you guys. Anyway, I'm going to stop rambling, so I'll see you in the code editor momentarily. Let's type this up. Back in the code editor, let's type this up, and it looks like Leetcode actually has a new UI here. It looks pretty clean. I kind of like it. What do you guys think? Let me know in the comment section below. Anyway, let's get into the problem. And the first thing that we see is that we need to return a list with all of our results here. So let's define that variable, and we're just going to say res is going to be an empty list. Now we actually want to define our DFS function, and I guess before we do that, we can just return res at the end, right? Cool, so we know that our DFS function basically needs to do all of the work. So we're going to say def DFS, and remember the things that we're going to take in is going to be our current index. We're going to take in our current result. We're going to take our current sum, and we also want to know what the previous value was, right? And remember, the previous value is the cases where we actually need to do multiplication, and we need to undo any previous addition or subtraction that may have happened because order of operations. Okay. So the first thing we want to do is actually check that we haven't overran our number here. So we just want to add a check that our index is still valid because we don't want to get any sort of index errors. So we're going to say if the current index is actually greater than or equal to the length of num, then what we want to do is we want to check if the current sum equals to our target, then we know that we found a solution. So we want to say res.append, and what we're going to do here is we're going to basically join together our current result, and we're going to join the current result, and we will add that to our result. Cool. That's what happens when we have a solution, and at this point we need to return because obviously we're still in this if statement, so we don't want to continue going further. So now we need to do the else clause, And what we need to do here is we need to build out all the possible values, right? So say we had like 1, 2, 3, we need to build out 1, we need to also do 1 and 2, and we also need to build out 1, 2, 3. So we need to basically go through all of those possible values and then explore all of the sub problems inside of it. Like I said, this is going to be a depth first search problem with some backtracking, so we need to keep track of basically all the possible options that we can go down. So we're going to say for I in range, from our current index to the length of num, we're going to say that the current value is going to be the num. So we're going to parse the current index. So we're going to say cur idx from our current index plus 1. And the reason that we want to do this is, remember that we can possibly parse out. So if we had 1, 2, 3, we don't want to just parse out the 1. We can parse out the 1 and the 2. We can parse out the 3. If we had a lot more numbers, we would just keep going. So we don't want to just stop at the single digit. We want to be able to parse as far as we can possibly go. So that's the reason that why we go from the current index to basically index plus 1. So that's going to basically parse them all out. So we're going to get the current string here. Obviously, this is a string here, so we need to basically convert it to an integer because we're going to be working with some sums here, so we want to make sure that it's actually an integer. So we're going to say the current num is just going to be integer of, our current string, right? Cool. So we've now parsed, our current number, and now what we need to do is actually just explore all of the paths, right? So one thing that we need to realize is that if we're at the very first number, so if we had 1, 2, 3, obviously our current result is going to be empty because we haven't parsed anything. In this case, we don't want to be adding anything. We just want to parse the first value and then move on because obviously we haven't done anything yet. So we need to just parse that first value so we can continue with our functions. So we want to check. Let's see, am I inside of my loop? So no, we're going to say if not curres. So if we haven't parsed anything yet, this is our very first index. So basically the index 0 in number. What we want to do is we want to say DFS. So obviously we're going to increase the index plus 1. And then our current result is just going to be that first value. So it's just going to be, the current string. And then what we're going to do is, our sum is just going to be the value curnum, and then the previous value is just going to be curnum, right? Okay, so we passed that in, and why is it giving me, okay, that's weird. I should turn that off. Anyway, that's what happens for the first value. Otherwise, if we have any other value, we just want to proceed normally. So let's do the addition case. So obviously our index is still going to get incremented by 1. Now what we want to do is we want to take our old current result, and since we're going to be doing an addition here, we actually want to do a plus here. So we're going to add a plus. And what we're going to do is we're going to add the current string. And so basically we take our previous result, we add the plus, because remember our result needs to be actually a list of strings. So we need to build out this result. So this is basically kind of us doing like a string builder here. So we're going to say current res plus, basically we're going to add a plus operator, and then we're going to add the current string to basically keep building it out. So right, if we had like 1 in our current result, then we want to add a plus, and then we want to add the 2 if the number was like, 1, 2, 3, right? So that's what we're doing there. So that is the part where we actually build out our current result. Now our current sum, essentially we're just going to take whatever the current, the previous value was for the sum, plus adding our current num to it. Pretty straightforward. We're just adding our current value to the old value. And what we're going to do now is we need to just update our previous value for when we go into the loop again. And the previous value is just going to be our current number. Okay, simple enough. Now what we need to do is we need to go into our DFS function. And why is this yelling at me again? Prev. No, it's right here. Okay, this is weird. Let's see if it just goes away on its own. I don't know what Leetcode is doing. I don't know how to turn this off. This is the new UI. Anyway, again, we want to increment our value here. So we're going to increment our value, our index, sorry. And again, we're going to do cur res, and we're going to do cur res. And this time, we're going to add to the list a minus operator. and we want to add a cur string. Again, it's going to do the exact same thing as the plus case, except for we want to just add the minus here. And again, this time, since we're subtracting, we want to say the current sum minus the current number. Obviously, we're doing subtraction here. And now the cur num will just be minus cur num in this case. And that's all we need to do. So let us now move to the multiplication case, which is the most complex case, but luckily we have set ourselves up for success here. So again, it's going to be the same kind of pattern. We're going to, instead of a minus, we're going to add a multiply here. And again, we're going to add the current string. Pretty straightforward. Now what we want to do is we need to undo the result of any previous addition or subtraction that we may have had. So we need to do that. And the way that we're going to do that is we're going to say the current sum minus the previous value, minus prev, plus the current number plus the previous value. And let's kind of sanity check this so you guys can see that this works. So say our number is 1, 2, 3, and say we had 1, 2, and now we're going to multiply by 3, right? So our result up to this case should be 3, and we want to multiply by 3 now, right? And this would give us 9, which we know is not correct because order of operations says that it should be 7. So let's think about what our current sum is, right? Our current sum would be 3, and the previous value would be 2. So what we're going to do here, let's look at, okay, what's the current sum? So 3 minus 2, and what we're going to do, right, obviously that equals 1, and to 1, what are we going to add? We're going to add whatever the current number is. Oh, this should be multiplied, sorry. Multiplied. We're going to add to it whatever the current number is multiplied by the previous. So we know that the current number is 3. Oops. So we're going to say, 3 times 2, which we know is 6, plus 1. This will give us 7. So there is how you get that value, and this is how it works. So basically, this part is undoing the last operation. This part is applying the current number multiplied by whatever the previous number was, and that's why we have previous in our function here. We need it for this case here. If we were just doing the addition and subtraction, we wouldn't need it, but unfortunately, because of the multiplication, we need to keep track of previous. So this is where it comes into play to basically undo the order of operations and make sure we get it the right way around. So that is the, actually we still have to basically define the previous value. So now in this case, it's going to be cur num times the previous, right? So that's what we want to do. Now what we want to do here is there's one last check that we need to do, and that is, again, for that trailing 0. So right, for like 105, we can't have 1 plus 05. It either has to be 1 plus 0 plus 5 or 10 plus 5. We can't have this 05 here, so we just need to check if we've actually started on a a leading 0, then we have to make sure that it's on its own. We can't continue through this loop here if the first value here, I, actually gives us a 0. So we're going to add a simple check for that. We're going to say if the current num of whatever the current index is actually equals to 0, and remember that num is actually a string, so we actually need to check for string equality here. We just want to break out of this for loop. We don't want to continue making it, right? Because again, if we look at 105, what this loop is going to do, it's going to get 1, or it's going to take 10, or it can do 105. And if ever we started on a 0, we don't want to parse, we want to do 0 and 5. We don't want to do 05 because that wouldn't be correct, because again, the problem says no leading zeros. So that is your DFS function. The last thing we need to do is actually call the DFS function. So let's call DFS. So the current index, obviously we start at the 0th index. Obviously our current result is empty when we start, so we're just going to pass an empty list. Our current sum, we haven't done anything yet, so it should be 0, and the previous value should be 0 because we haven't seen any values yet. So let us run this. Hopefully I haven't made any mistakes because this problem is quite complex. Okay, it seems to be accepted. Let us submit this, and judging what happened. Okay, cool. So we are done here. That looks like it was accepted. This is a new UI, but okay, it seems fine. The solution was accepted and kind of got lost in the new UI, but the last thing that we need to do is actually just talk about the time and space complexity. So for the time complexity, let's think about this. When we go through our recursion, there's actually 4 paths that we can take, and it looks like there's 3, but let's think about this, right? We can go addition, we can go subtraction, we can go multiplication, or we can actually choose to ignore the current operator and move on to the next one. So this is in the case, if we have 1, 2, 3, remember we can do like 1 plus 2, or we can do 1 minus 2, we could do 1 times 2, or we could simply ignore it and actually build 12, right? And then go on with like 12 plus 3, 12 minus 3, yada, yada, yada. So those are the 4 cases, right? We have the 3 here where we're actually adding the operator, but 1 is implicit in that we actually just ignore the current number and move on so we can build a higher number from the next digit onwards. So you have 4 cases, and since this is backtracking, this would basically be 4 to, let's see, time, what happened to my thing here? Okay, it's gone. So basically we have 4 cases. So since it's, we're calling it recursively from each one, it's going to be 4 to the n for the actual DFS part. But we also need to recall that when we get to the end, we actually need to call dot join on our result. And obviously dot join is going to take n time. So our final time complexity is going to be, 4 to the n times n. So quite a complex problem, but as you saw, the solution was accepted. So, it's not one where you can really optimize on this. It's just you have to generate all of the possible options. So for the space complexity, we just have our result here. So our result is basically just going to be big O of n. The number of results that we actually generate is going to depend on how long our original string is. Because that's going to determine, all of the possible things. In the worst case, literally every single possible combination will add up to the target. And this is the worst case where actually all of the numbers in the thing are 0, right? So no matter what you do, 0 plus 1, 0, 0 minus 0, 0 times 0, it doesn't matter. If the target is also 0, then every single possible combination of adding, subtracting, and multiplying will actually just give you 0. So in this case, the number of solutions we have is going to be dependent on how many zeros we were basically given. So that is why your space complexity here is actually big O of n. So let's kind of just add the big O's here. Big O of n. So that is going to be your time and space complexity. Like I said, this question, it's rated hard. If you've never seen this before, you're probably not going to come up with it. It definitely took me, a few times actually looking at the official solution to figure out how this works. But I think once you've seen it, it is quite intuitively simple. Basically, you're just building out all of the possible solutions here. The only real trick is the fact that you can actually build you're not just doing single digit things. Again, you could have 1 2 3 and you could parse that as 1 2 3 or 12 plus 3, or you can even have 123. So parsing that is one of the tricks you need to kind of figure out here. Also, you need to know how to deal with the multiplication. And then also to kind of check this edge case for the leading 0, but it does tell you that in the problem description. Anyway, I'm going to stop rambling because this video is probably 20 minutes long. So that is how you solve expression add operators. Definitely a good one to know. I think it's asked, let's see, let's go back to the thing here. Where is it asked? At Facebook and Google. So if you have interviews at there, they might throw this at you because it's a hard question, but it's not ridiculously hard. Like, this is probably something within the realm of, something you'd want to be able to solve. So that was the question. Hopefully you enjoyed this solution video. If you did, please leave a like and a comment. It really helps me grow and pushes me in the YouTube algorithm. Subscribe to the channel if you want more content like this. Otherwise, thank you so much for watching and have a great rest of your day.